Hello, we are the AgBiz Logic Capstone Group. My name is Miguel, and my teammates include Allison, Atlee, Robin, Ksenia, and Matt. Today we will be showcasing our implementation and development process of a tool for analyzing environmental and economic trade-offs of agricultural chemicals. This tool will be added to the AgBiz Logic platform. We want to start off by thanking our project partners who have supported us and given us valuable feedback throughout this whole process. Clark Sievert and Sean Hammond. Our goal with AgBiz Logic was to incentivize best growing practices while keeping cost effectiveness in mind. Our method for achieving this was to leverage an environmental impact quotient, or EIQ. By using this value, we were able to produce accurate scores for growing land by taking into account different sizes of land and automatically converting measurements for growers. With this, we hope growers take full advantage of this new feature we've implemented.
Hello, my name is Ali and we had three main highlights for our project. We had the extraction, the API, and the table that we built. So to start off with, the extraction, we needed a way to extract the data from the Cornell database, and then we needed to be able to create an API from that data so that we could pull that data and then put that into a table so that the end user can see that data, select that data, and then see more information about the thing that they selected so that they can compare chemicals and review any other data related to them.
Our steps. First, we developed a data retrieval script using Selenium to download Cornell EIQ data and format it into JSON. Once we had this information in JSON, we were able to build an API endpoint to retrieve a list of chemicals for a specific budget, including details like the unit, the quantity, and the type, which is information needed for the EIQ calculation and field use rating. And then we created a breakdown table UI that displays chemicals from selected plan in the environment module. And it calculates their overall EIQ field use rating for the whole plan and allows users to add, edit, or remove chemical data and compare it to other plans. We mostly followed our initial plan. However, we originally were going to have a separate breakdown and overview for EIQ, kind of like a high level overview, and then you would be able to click on a plan and learn more. But after talking with Sean, we ended up integrating it, the EIQ overview and the breakdown together in the form of a drop down table, as we mentioned before and will show in the demo. So that was kind of the only big difference in our development plan. We learned about the importance of teamwork during integration and adaptability when plans evolve during development. For example, this one, we kind of had to shift roles. So I'm going to do a quick front-end demo that will show some of the things we outlined in the highlight section. So this is how the EIQ is generated. This is a warning error that comes up if any of the practices have units that can't be converted or are not compatible with each other. And then this is the table that was mentioned. So each plan that, each practice that they have will come up. So if you had another one, the baseline, if you had more, they'd come up. And you can compare the EIQ. And once you have EIQ values, the percent from the baseline will be calculated. The drop-down feature we also mentioned. So right here, as you can see, the EIQ values are missing. So that goes to part of the backend that we highlighted. We had to scrape the information from the Cornell database. And they obviously don't have everything. So if something's missing, it will show up like this. If they do have something, like these values, it will show up. And that's using the API that we highlighted, is how the front end can get that information. And then the dropdown also has features like editing. We have a drop down here and here with all of the chemicals that AgBiz Logic supports. You can change the active ingredient. You can input your own EIQ. And then we also have an auto convert feature. So if a unit is convertible to each other, say if they want to change liters to pints, it will automatically convert for the user just to make their lives easier. Okay, so that is everything that we did on the front end and how it kind of fit in with the back end team's work.
My name is Robin. I'm one of the AgBiz Logic Capstone team members. What I wanted to show everybody was how we were able to incorporate the environmental impact quotient into our project, which is a metric developed by Cornell University. The EIQ is a metric, as I said, that's designed to try to calculate the risk of harm from using any given chemical in an agricultural application. And so, as you can see here, there's kind of a burly sort of weighted average sort of equation happening here. And what I really want to show you is that it can be broken down into three main sections. The risk to the farm worker, so the people who are applicating the chemical, the pesticide or the fungicide, what have you. And then the risk to the consumer, who could be us, getting the carrots at the grocery store if there's any trace chemicals. And then finally, the largest group here is the risk to organisms in the environment where the crops are being grown and sprayed with that pesticide. Continuing on, so our friends at Cornell University have put a lot of work into researching this EIQ value, and many different chemicals can be found that they've done this research on. And so, thinking back on our equation, we have each of those three groups with their own EIQ value here. The final EIQ value is calculated by summing these three values and then dividing them by 3, just an average of the 3 different groups. Now, we as software, we don't work very well with Excel spreadsheets when we're trying to develop like a web application. So our goal on the back end was to create a pipeline that can automatically download this file right here, this spreadsheet, and convert it into JSON, which is JavaScript object notation. And so here you can see I've got an example, and this is a machine readable language, and then our front end API can grab whatever information the farmer be using. And so in their budgets, they can take this information, calculate their EIQ, and then weigh that against their profit margins. Thanks for listening.
Hi, this is Matt DeMichael, one of the members of the team. To conclude the presentation, we just wanted to note that after the capstone project concludes, the project will be merged into the main AgBiz logic repository and eventually integrated into the live application, where it will be used by actual farmers and producers growing real food. So on behalf of myself and the rest of the team, we just wanted to say thank you to our project partners, Clark and Sean. Thank you to the rest of the teaching staff, and thank you on behalf of the team.